Hello, my name is Matt Brophy, on Twitter and GitHub, BrofDog11. I work for Remix, recently acquired by Shopify, so I'm now working on Remix at Shopify. But I want to talk about use the platform with framework agnostic routing today. So it's worked out well that today's lunch panel kind of harped on use the platform so much. I promise I didn't change the title. This was there to begin with. But it's a big tenet that we with the Remix framework believe in, so it's something we've really been focusing a lot on this year. So for those who aren't familiar with Remix and/or React Router, Remix is a server rendered framework based on React Router that was released in 2021. React Router goes back much farther than that. It was created by Michael and Ryan in 2014. V6 was just released late last year. And then just this year, we released version 6.4, which has this data routing capabilities we're going to talk about today. But these stats here, just to show you that it's a very popular React framework. So it's been around a while. It currently has 8 million weekly downloads. And just recently passed over 1 billion downloads in the history since it was released. So for a router that big and that popular in the React ecosystem, you might wonder, like, why now? Why make big changes in this 6.4 release? And the answer is really just that what Remix has come up with in the way that Remix is loading and mutating data is just too good to not offer to React Router apps. It's not something that we felt could be, capped and isolated to those that want to opt into server-side rendering with Remix. The patterns are just really great. So I want to talk about how we're making those patterns available to React Router users and users of other frameworks as well. So the package we're going to talk about today is the new package we just released with React Router 6.4. It's the Remix Run/router. It's a framework agnostic data router that mixes all of the Remix data loading and mutation APIs and combines them with the React Router route matching and history management stuff that is all going on for your single page apps. We realized early on that this isn't a React problem. Every app, regardless of written in React or Vue or Svelte or whatever, has to load data. It has to change data. It has to render your routes according to the URL. So those are not React problems. And we realized pretty early on that we could come up with solutions that weren't React solutions for those things. These are web problems that we should be able to solve for any framework that you choose to use. So with that, we built this thing with the idea of being framework agnostic, and it turns out it has zero dependencies. So this is a package on NPM that's just only the JavaScript in that package. It's not tied to anything else. So the question of why data routing, why are these patterns important is covered really well in 2 talks that Ryan gave earlier this year, and that kind of sets up why we built this router. But I would highly recommend you go and watch these at some point. They're both pretty quick, 20 or 30 minutes. But they explain, why we want to load data this way and why we want to mutate data in this way. But today I really want to focus on the how. I want to talk about how we took a working Remix and React Router product and we extracted out the things that we needed to be framework agnostic in such a way that we can now layer on top new frameworks and hopefully down the road support things like Preact or maybe Vue in Remix itself, and at the very least have single page application React Router alternatives for those. So I'm going to really quickly touch on some of the why, but I'm not going to dive in anywhere near as deep as those 2 talks go. So the status quo for loading data today probably looks something like this. If you're writing React, we're fetching in components quite often. So you have a component, it's managing a little bit of state, it's kicking off a fetch inside of an effect, it's setting the state, showing a spinner while we're waiting for that fetch to come back, and then eventually rendering the UI. This is a pretty common pattern, but it has a number of errors and edge cases that we haven't accounted for in this simple code. So if you think about this, we haven't yet thought about how do I update the data if my route changes. We haven't thought about what to do if that fetch call fails and we want to show an error to the user. We haven't done anything to handle race conditions or canceling requests that have already gone out, and I click through a couple links really fast. And we've done nothing to revalidate our data. So if I change data from somewhere else on the page and this data is now stale, how do I get that back up to date and make a new fetch? So if you want to handle all that, your component probably starts to look a little more like this. So we've added an abort controller so that we can cancel fetch requests. We're now listening to the URL as a dependency of that use effect. We're handling failed calls with an error state. We're rendering an error UI. So it about triples in size to handle this, and we've still not done anything about revalidation. So for that, you might reach for React Query or another library. There are tons of libraries that do this stuff. But at the end of the day, if you're doing your fetching in your components like this, the best UI you can give your users looks something like this. We've got a spinner when we make our first fetch call, and then another spinner lower down on the page when we make our second fetch call. And we've got this waterfall of spinners all the way down. And we really think that we can do better than this. This spinner-driven UI is not the greatest thing to give to our users. The problem is that we're currently we're blocked in figuring out what to load. So really what happens in this, what I'm going to call render then fetch, so first we render our component and that kicks off our fetch, is we get a waterfall like this where we render our app component and then inside of there we decide to fetch the data the app component needs. When that fetch ends, it's blocking, it's latency bound, we don't know how long it's going to take. We can then render the children. We might render the invoices component and that's got to fetch some data of its own. And then when that's done, we wait, we render the invoice component, that's got to fetch data. So you get this like sequential blocking render fetch lifecycle. So the waterfall is bad. We know that from the DevTools network tab. We're getting a waterfall because of the way we chose to fetch in the render lifecycle. So really what we want to do is we want to flip that. We want to think about how do we fetch and then render. We want to be able to fetch our data ahead of time so by the time we render, it's just a quick render pass. Rendering is fast, fetching is slow. So in order to do that, we have to find a way to decouple from our rendering step. We have to decouple route matching. So what routes do I want to show for a given URL? And therefore, we have to also have our route definition decoupled from that as well. We need to know what routes are available in order to match them. And we want to decouple data fetching. So if we can get all of that out of our rendering, we can make our flow look a little more like this, where we can fetch things presumably or optimally in parallel, and then we can render everything in one pass without blocking at the render step. So the question is sort of like, how do we accomplish that? So I want to take a look at sort of what render then fetch looks like from a user interaction standpoint. Generally, we'll be sitting on a rendered UI. The user clicks a link that points to a new route. We're going to, because it's a single page app in React Router or something, we're going to prevent default on that link and avoid it going to the server. React Router is going to push state to the history API. And then the render cycle is going to take over here. And we're going to get in this little loop of like, render the first component, fetch data, set state. Render the child component, fetch data, set state. So we get in this little loop here, and all of that prevents us from reaching our final state of a fully rendered destination page for the user. So we want to get rid of this. The question is like, how do we do that? So we always look to like, what would the browser do without JavaScript? The browser is a data router. The browser's been around for a long time. It's solved a lot of these problems. Like I said, we really believe in that use the platform. So if we were to go back, turn off JavaScript and just look at like a slow loading multi-page app navigation. In this case, I've got 2 pages. I've got a 5-second delay on them. So I clicked the second link there to the About page. And as soon as I click that, you'll see that we get the browser spinning the fave icon, and we get the browser telling us that I'm going to a new route, but nothing else is updated. The URL is still showing me the current location, and the URL and the page contents are still showing me the current location. So the browser is already doing this fetch then render. Once that fetch comes back, the server sends a response, the URL updates, and our page contents update, and the spinner goes away. So we actually have a really good sort of like thing to go off. How do we want to implement our fetch then render? Just emulate what the browser does. So the browser in a multi-page application navigation, you're going to click, it's going to make an HTTP request to the server. It's a literal request of, can I have the contents of this new URL? The server is going to do whatever data fetching it does. The server is going to render HTML, and it's going to send it back to the client. And at that point, we're going to update the URL. So if we wanted to change this and base our single page application routing lifecycle off of what the browser would do, and there's in that diagram, we have sort of a clear delineation of client and server. But in our case, everything's on the client. So we might make it look something like this. So we've got, we're going to click the link. We're a single page app, so instead of sending a request to the server, we're going to prevent default, and we're going to handle it ourselves. Instead of doing a server fetch, if we could match routes and fetch right there client side, once that fetch is done, we could set our state with the data we got back and update history at that point. So we're flipping the URL update and the router fetch. And then the client can render in response to the new state rather than in response to the URL updating. So there's a slight change in the order of operations here, but it turns out to be really powerful in some of the UX and DX that it unlocks. So the question again is how? How do we match these routes ahead of time? So the answer turns out to be, again, using another feature of the platform, the URL. It's something that has gone a little bit overlooked in the past years as we've moved a lot of our state down into our application. The key here is we're sort of lifting state all the way up to the URL. The URL is the state of the application location. Where are we is driven by the URL, not by state inside of a component. So if we combine the URL and the nested routing that React Router v6 has, we can actually get a really good way to match routes ahead of rendering. So nested routes, if you're not familiar, refers to when different subsections of your user interface corresponds to portions of the URL. So in this case, with this Fakebooks app that a lot of the Remix documentation uses, we have like a left nav that we can go through our account, our sales, expenses and whatnot. Then we have a top nav up top, and then we've got invoices all the way down. But if you look at the URL at the root level, so the domain, we're fetching maybe information about the user that's currently logged in. If we go one level deeper, now in the sales portion of the URL, we have a sales section because we've clicked the sales link in the left nav. That's got its own information. In this case, it's the nav for that sales app. If we go one level deeper, we're now at the invoices nested route. That's showing all of our invoices. We had to fetch them. So there's a fetch call there. And then for the specific invoice that we've landed on, we have the invoice ID. So we get 4 nested sections of the UI that are tightly coupled to portions of the URL segment. So with that, we can actually use the URL, which we know because it was in the href on the A tag that got clicked, and our nested route definitions to match ahead of time and know what routes we need to fetch data for. So what this looks like in a current React Router app, so I'm going to kind of show you how we would extract this information out. So this is a pretty similar React Router 6.3 application. You use browser router, you render maybe like your nav bar and stuff up top, and at some point in that sort of root level app component, you have your routes component itself, and then its children are all these little route objects, and those tell us the portions of the URL and the routes that they map to. So that's what we need. We have the information. It's just like buried down inside a React render lifecycle, so we can't get to it until we've already told React to render. So the first step in here is to take this like non-route stuff, which holds maybe our nav bar and everything else outside of routes, and convert that to a layout route. That's generally the pattern we recommend, but because you don't need to use a layout route in V6, you can just put it right there in your root app component. So if we put that stuff in a layout component, it's going to render the app shell. We can render all of the children inside of there. Now we've lifted it so that all of our routes are at the root of our render tree. So we don't have like other things we're going to miss about our UI. We have that all in the layout route. So the next step is how do we get these route definitions again, lift them up and out of the React render step. So what's interesting here is if you actually look inside, these look like React components that are going to render. If you look inside the code of React Router, this never actually renders anything. When you get to the routes plural component, it walks the JSX children tree and generates a structure like this, which is just an array of nested objects, of path segments, children, and element components to render when we match those paths. So we already have the information we need in a React agnostic way. We know the routes. We just need them out of that render lifecycle. So once we can lift them out, and we'll show you on the next slide, where we put those, we're going to just start defining them outside of the lifecycle in the standard object array syntax. Now, if we know the routes, what we can do is add a loader function to each one of those. So we can say, just like on the screenshots a few slides ago where we said each nested route had to fetch some data, we can add a loader function to each route definition and say, this is what will fetch all of the data needed by this route. So anytime you're going to render this route, I want you to run this function ahead of time. Fetch me all that data before you render it. And you'll see here we're giving that loader a request object. That's just a fetch request. So that's the thing you prevented when you called prevent default. We were about to send a request to the server. This is a single page app, so we prevented that. And we're just going to hand that request off to your loader function, and you can return whatever you need from it. So again, that's just another thing. You'll see a lot of these like built-in web platform APIs. These aren't specific to Remix or React Router. These are built into your browser. We're not shipping any code for these, so we really want to lean into that, use the platform. So at this point now, if we take all of our routes and we define them outside of the React tree, and then we create this agnostic router ahead of time, we can just hand that off to React and render it. And we get this really clean separation of what's responsible for routing and data loading and what's responsible for rendering. So now we have the ability to make everything above this orange line has nothing to do with React anymore. Above this orange line is what are my routes, what parts of the URL do they correspond to, and what do I need to call to fetch the data for those routes. So this is really the separation that we were striving for so that we could start to think about what does this look like in a non-React world. So going back real quick to this very large component when we were doing in-component fetching, it's interesting to kind of break this down and look at all of the data that we actually are dealing with in here and everything this component does. This component is initiating and canceling a fetch. It's reading the fetch result and also potentially the error if it wasn't a 200. It's managing the success and the error state from that fetch in React state. It's listening for route updates to re-trigger that fetch. It's rendering the spinner, it's rendering the error UI, and it's rendering our happy path. So there's just a lot going on in here. So if you've heard of the single responsibility principle, this is an area where I think we can say we're not really following that. We're doing a lot of things in here, and this component can change for many reasons, every one of which could potentially break some other aspect of it. So by lifting everything out into the router, let's look at what we would do to cut these down. So our router is now going to handle these top 4. The router is going to call the fetches. It's going to call the loader functions you provided. The router is going to read the results. The router is going to manage all that success error state based on whether the loader resolves or rejects. And the router is going to be dealing with history and listening for route updates. So we're left with these bottom 3. Now our component's just rendering, which is good. React is a rendering library. So now we're doing the thing React was really built to do from there. I would also argue that the spinner tends to go away in most of these cases because we're not rendering a spinner per component. You're generally going to have one sort of global loading indicator. So the spinner goes away in all but one of your routes. Generally, the root route has something going on. So we're left with maybe something that looks like this. So that's not a real hook. We're going to get rid of that in a second. But our component at this point would just be like, the router has already fetched the data. So just give me either the data or the error from the router. And then I'm going to choose to render my happy path UI or the error. But we still think that's tricky, right? Because it's still a branch in our code where now we're thinking about 2 different things at this component. We want to get to the point that we can just think about happy path most of the time. And if there's an error, we can deal with that in a separate area. So a way to do that is to just add alongside of our elements. We already have the ability to say when this route loads, render this element. We're just going to put a sibling right next to that and say when the loading data step fails, render this element instead. So now we have an either or decision that's happening at the router level, not down inside of our components. And that allows us to, one, by doing this at the nested routing level, we can do contextual error boundaries. So what we're saying here is if you look at this error, this O snap in the bottom, if loading a certain invoice fails, there's no reason we have to blow away the entire UI. The only thing that we couldn't fetch is that bottom section. So by putting an error element all the way down in the nested route at that level, we can just show the error there and leave the user the ability to click around to a different invoice and try to come back to that when maybe it passes the second time. So that's really neat. But the other nice thing from a DX standpoint is that our components look like this. We now have 2 components that are completely 0 forks. We have a happy path component in invoice, and we can guarantee that anytime that renders, I'm going to have data from that use loader data hook. That's going to return me the data that the router fetched, because we're not even going to bother rendering that component if the loader rejected. And we've got an error component that we can promise if that component renders, there's going to be an error, because we won't ever bother to render that if there wasn't an error triggering it. So we've gotten rid of all this, like, if my state is in a certain place, do this, and I don't have to check to make sure that it's not null, and I'm not worried about that. I can just think about, given when I'm on this route, I'm going to have this data, I want to render this UI. So we start to think just about rendering, less about the data lifecycle information. The other interesting thing here is where did the React code go, right? We don't have a single use state. We don't have a single use effect. We're just saying give me data and let me render it, which is awesome. That's what React is built to do. That's what libraries like Vue and Svelte are really good at, is given UI is a function of state. Give me some state and I'm going to render out HTML. We get to actually reduce the components we write back to that sort of original thing that made React and Vue so great in the beginning, is that component rendering is really powerful. But over the years, we've ended up with a lot of this data fetching logic, and it's gotten more and more and more complex to write these components. This is a much simpler way to author components when you take that data fetching responsibility out of the component itself. So with that, I want to take a quick look at what this looks like in an application. So any Vue developers in the room here? Yes, we have 2. Awesome. So this is show up. This is the demo is written in Vue. This is with a Vue package that I wrote on top of this framework agnostic router. We have a Svelte package as well. I link to them a little bit later on. But I wanted to show folks what the loading looks like here. So let me quick fire up the server. And let's go load. So being an employee of Shopify now, I get access to all of the cool Shopify Hydrogen dev data. So I've stolen all that. And this app is just running off of show it over here, an MSW instance. So I'm just mocking all of these API endpoints to read from static JSON files. So we're not going out over the network or anything, but I have sort of mimicked some slowdowns here. These calls are going to throttle to 500 milliseconds to show what it might look like for real. So here we are on the home page. And let me show you real quick what the routes look like too. There is the app. So here we are pulling in create browser router and router provider from the Remix router view package, which is using this Remix run router to add a view layer. We're defining our routes, so we have a root route that has a loader. We have the home page as an index route child of that. And then we have a collection page, which is like all the tiles of the products in a given category. And then we have a product page. We've got some loaders and actions on those. And then finally, at the view level, the only rendering we're doing here is just saying, here's the router, render this out via view. So we're gonna go over here and just click through. We can go to, you'll see when we first load, we make an API call to load the collections. That's for our nav bar up top. Freestyle and backcountry are driven by an API call at the root loader. When I click to freestyle, you see a little spinner as we load the tiles for this category, the products in the freestyle category. And now we get all these. We can click through and go to a product. You'll see here that we're now loading the product itself. This is the specific snowboard product. And we get, a little sort of add to cart UI here. But what's really neat is that our back button still works, the way that the browser would work to begin with. That's another common problem in single page apps is we often break the back and forward buttons. And we've got all this, all this stuff here that you would normally see on like an e-commerce category page. We can sort by price descending. We can sort by alphabetical. Make this a little thinner here so we get those back on one line. There we go. We can go by alphabetical ascending, alphabetical descending. We can click through and maintain those sort orders. So this is a pretty common sort of e-commerce use case. You'll see here as we're going through, we're just making API calls to those loaders each time. But what's really interesting is that looking at the code for this, normally folks would almost expect to like see a whole bunch of those use states and use effects. So I want to look at the code that drives the UI there. So at the root level, we have a loader, and that loader is just making a fetch call to fetch those categories along the top nav, the freestyle and backcountry. You'll see here we're just making a fetch call, and we're passing it the request signal. That's important. We'll look at that in a second, but that's what allows us to do cancellation at the router level automatically. But the other interesting part here is that the loader response understands the fetch response API. So nowhere in here did we have to like await res.json to get the data. The router knows how to deal with it. The router speaks the web fetch API. So if you hand it back a fetch response, it's going to know what to do with that. And then rendering in the root component, we have 2 lines of sort of view specific code short of our template. We're going to grab the data from the loader and use loader data, and we're going to grab the current navigation state. That's going to let us show a spinner. We're going to just render our spinner anytime the navigation state is not idle. So that's going to go into a loading state as we're routing and fetching data, and back to idle once we land on the destination URL. And then we're just going to loop through and render the categories as links in the top. So there's nothing really view specific going on in here. But I think what's even more interesting is going to the collection page. And this is where we're doing all of the filtering, and pagination, and sorting, and all of that. And again, if you look at this, we have exactly 2 lines of view-specific code to manage all of that, because all of that's being done in our loader via the URL and request object. So the platform gave us everything we need to do sorting, filtering, pagination, and everything. So looking at our loader, this is going to be where most of our logic lives. So as a loader, we get in that fetch request. We're going to grab the URL, and we're going to parse out the 3 different parameters we care about. So if you notice, everything there, all of our state is living in the URL here, right? So state like this often belongs in the URL. It allows us to share these URLs to folks and get the same exact load if we load that up. But we're going to grab the page, sort, and order. We're going to fetch data just using a fetch call. We're going to grab the data off of that. And here, just for this demo app, I'm doing client-side sorting and pagination. Most often, you'd pass these parameters straight through to your API call and get them back in a certain way. I didn't bother to do that. So we're going to sort them locally based on whatever sort order we specified. We're going to generate the links for the previous and next page if they exist, and null them out if we don't have a previous or next page to go to. And we're going to return back from our loader all the data we need for the UI. So that's going to be the category title, the products, all the sort ordering and stuff, and then links to the next and previous page. And then now we have 2 lines of code. We say, give me the data, right? Once it succeeds, I've got everything I need to render that UI. I don't have to do any kind of like, in Vue, it would be a ref or like an effect or a watch effect. In React, it would be use state or use effect. And I'm going to grab the current location so that I can generate all of these filtering links. So then from a rendering standpoint, we just have our sorting. Sorting is just a link. There's nothing special going on there. There's no click listeners. It's just a link to a new URL with a new set of state that tells us what sort order we want. We're using location path name because we're linking to the exact same category page that we're already on. Pagination, same thing. They're just links all the way down. We have no click listeners to deal with pagination. We just render the link that has the right URL parameters for the page we want to go to. And then the grid is, again, just links to the products themselves, showing an image and some title and price information. So I think what's really incredible to me with these patterns, when you think about things in this like component-based nested routing, loaders and actions, all of the code that we used to write just sort of falls away. So like the React specific code that you had to be potentially really good at React to know how to deal with effects and put the right dependencies in. You had to be really good with the Vue composition API and know about how its reactivity works under the hood. You don't have to think about that in these happy path scenarios now. You just get to say like, here's my data, run my loader, fetch the data, and then when it gets back, we're mostly just using React, Vue, Svelte, whatever as a templating engine at this point. We're just rendering the data out. And that's a very like preferential thing. Some folks love JSX, some folks love Vue templates. You're never going to find a one-size-fits-all answer for those. So having that flexibility to let developers use the thing that they feel most comfortable with or what's best for them and or their team is really powerful. The other thing I think is really neat is that this loader, because we're using the platform and we're using the fetch API, there's zero React or Vue or Svelte specific code in this loader. So everything you learn writing these loaders and actions is fully transferable. If you're learning these things, you're learning the web platform. You can take this to a different job using the web platform. It's not, I learned all this stuff working on this project at this company for 4 years and I just went to a new job and I got to start all over again. So let's take a quick look at, we pointed out the request signal that we're passing around. So we always give you a request. In the platform, requests have a signal. It's an abort signal that if that request gets aborted, you click to a different page, that's going to fire. We use those internally, so fetch will respect those. So by passing the request signal we get into our fetch call as its signal, if we cancel those, the fetch call will get canceled. So let's take a look at what happens if I clear this out and I click through a couple products really fast. Oh, so I didn't get to the third one fast enough, but you'll see that I clicked the first product and it started to load this mail-it-in freestyle snowboard. And as soon as I click to the next one, our router internally is triggering that abort signal. Because we passed it to our fetch, that fetch is automatically getting canceled. So we don't have to necessarily remember to deal with cancellation ourselves. We just have to send that signal along and the router will take care of it, which is really cool. One other thing worth noting, if I go to the home page to start, there are some built-in optimizations in this nested routing loader concept where our route loads the collections for the top nav bar. If I click through, we don't have to reload that. When we're reusing sections of the UI, we're not going to recall the loaders for those until the data changes. So we'll talk about mutations shortly. But as I'm clicking through these things, back, forth, over to another product, we never make this API collections call again. We never have to load the data for the top nav because we haven't done anything that would cause it to change. All right, let's jump back over to the thing. There we go. How are we doing on time? Okay, so we looked at loading. And I think there might be some folks out there, if we have any old AngularJS developers in here, I did a lot of that back in the day, but might have some folks sitting there saying like, hey, congratulations, you just reinvented Angular UI or Angular UI router resolvers, right? Like we were able to fetch data at the route level ahead of the thing back in 2014. I did it. It worked pretty well. It didn't solve everything. Angular still has these resolvers. They work great. Vue router has had this since it first came out and before resolve and before route enter hooks. So and React Router v3 actually, and I never used this, so I don't know anything about it, but it had a will transition to hook that I think allowed you to do something similar to this. So by no means are we trying to say like, we came up with this new novel thing for loading data before you go to your route. But I think we have a lot of other things that we've added onto this that make this really cool. And these are the parts that I think are truly novel and I have not seen in a SPA library before, let alone one that can be used with any rendering framework. So data mutations, I think, is the biggest thing that I haven't seen in other libraries out there today. So we've focused so much on how do I load the data to render this page, and then we just kind of stop. And nobody ever talks about like, what's the pattern for mutating data? So if I make a change somewhere, how do I tell these things they need to reload? Like, does the user have to do a hard refresh? What if the data is on two different parts of the page and the thing I changed down here has to update, for example, my cart count in an e-commerce thing? I add to bag in the middle of the page. I need to rerun that thing to tell me I've got a new item in the cart. So mutations are built into this as well. Going back to kind of mutation status quo, what would we do today in this sort of component-based fetching? We would probably have some controlled inputs with use state. We would have an on-submit listener that would immediately cancel the submit event. We would serialize that data into JSON manually. We'd make our own fetch call and send that JSON along and remember to set the content type. And with all that, we'd still have to think about errors, pending UI, interruptions, everything we had to think about in the loading data component. So if we go back to what these components look like, and this is not using mutations, like what happens if this is now mutation aware? Does it triple in size? Like we have a lot more code in the component when we start to think about how does the user change data, right? Web apps are great. If it's a static content site and you only have to load data, that's awesome. Most important web apps these days have some way for the user to change data, and that's a really important and I think often overlooked part of frameworks these days is how do we deal with mutations. So looking at these again, we're going to think about how would the browser do it. We want to emulate the browser. What would the browser do? Does anyone know the difference between these two bits of HTML? Anybody? Shout it out. Almost. They're the same thing. So the default behavior for form in the browser is method get. Surprising. It's normally, what the browser does is if you submit a form without specifying a method, it serializes all of the query data, all of the inputs from that form into the string, and it does a get request. So they turn out to be the same exact HTTP request if you don't specify method post. So again, what would the browser do? Links and forms are both navigations. They're the same thing under the hood. It's a navigation to a new URL. The only difference is that if it's method get, which is a default, if you leave it off, that form data gets serialized into the URL as search params. If it's method post, that form data gets serialized into the request body. So that's the only difference, but these are both navigations. And this, kind of what we realize is that we already have a router. That router knows how to handle navigations. What does that router need to do to handle mutation navigations when there's a form body with data? So what we want is our DX to look something like this. We want to be able to just use a form. Note the capital F, that's the form exported by React Router or the Vue package, because we do have to do some listening in the middle, but we want it to feel like you're writing an HTML form. So if we have a form method post, when the user submits that by clicking the button type submit with 0 event listeners, all our router is going to have to do is we want to create a request and attach the body to the request. And you can do that using another platform API, form data. So in any browser, you can just say new form data, pass it the form element, and it's going to serialize that data up into a form data API. So again, we don't have to manually serialize this. There's a built-in API that can do this for us. And what we're going to do, just like we added loaders to our different routes, we can now add an action function. So the naming here comes from the fact that you put form action to tell it where to post to. We're going to have an action function defined on our routes that says, if you post to this route, here's how I'm going to handle it. We're going to hand that action a request, just like we do with the loader. And then inside there, we can read the form data off the request with the request form data method. We can use the form data API to grab the values of the inputs that were submitted. And we can talk to our databases or whatnot, do what we have to do based on the form. And then just like we would have done in a multi-page app, we can redirect the user so that the data reloads. So let's take a look at what this looks like. This was the diagram of our browser emulator before. And we've got this section at the bottom, match routes and fetch. So that's what we got to change. So what we need to do to make this mutation aware is basically put a small fork in the road. And we just say hey, now it might have been an A tag click. It might have been a form submit. Both of those are navigations. We're going to prevent default and hand it off. And now we're going to look and say, is this a method get? If so, call all the loaders, do the same thing we were doing for clicking around and doing links. If the method's post, we add this one new section. We're going to find the route we're posting to and submit and call that action, hand it off to the request. And then we're going to continue along the same path. We're going to recall all those loaders to make sure we get the new data back. So this flow means we get automatic revalidation. So you don't have to do anything in your code to say, hey, data over here on the page relies on this. I changed it. I need to go reload that stuff. So things that you would have had to do before just kind of fall out of the code you have to write because our router is now aware of the data in the application. So let's take a look at what this looks like in a quick demo. So the form we're going to use here is the adding to cart. So real quick, I'm going to go add a cart count so that we have something to update. So I'm going to jump over to my root route, make a small update to my loader. So right now the loader was just getting the top nav bar. I'm going to uncomment this. We now have two different async methods, one to get our cart count, one to get that top nav bar. So our loader is going to do both of those. You'll see here it's going to do an await, promise.all. We're going to make those calls in parallel and return back the collections and the cart count. And then I'm just going to go ahead and render the cart count. So now we should, 43, I got to clear my cart. I was testing this earlier. It's an expensive cart. Let's get rid of that in local storage. There we go. So now we're starting a fresh session. We have no items in our cart. And what we're going to do here is go ahead and pick what we want, and we're going to hit add to cart. And I've got it delayed. Make sure I don't have the slow flag turned on. Nope, we don't want slow cart yet. We want that later. Okay, so pick whatever size I want of the snowboard, add it to cart, it submits, and that cart updates. So if we take a look at what goes on in the network tab here, let me clear this into a fresh one. We make a post to our cart API, so that's the action calling a post, and then it's going to turn around and make, it's going to recall all of the active loaders on the page because we don't know what changed from that action. It could have changed any data on your entire site, so we recall all the loaders by default. There are ways to opt out of that for performance optimizations, but we're going to recall the root collections, that's the nav bar up top. We're going to recall the cart API to get the updated cart count, and we're going to recall the loader for the product page, which is get us the product data again, because we, again, may have changed that. The router has no idea what your mutation is actually changing. So let's take a quick look at the code for this. Go over to our product component. And again, here we go down to the view component itself. Plain HTML forms. We're using this capital F form component. That's the view version of form exported from this Remix router view package. It really just knows internally how to listen for that submit event from the DOM and proxy it through to the agnostic router. We're just using normal inputs here for the different variants of these products. And then we have a button type submit. So no listeners, no state. If we go up top here, same thing as our other two pages. We're just getting in the loader data. And in this case, you'll see we're getting the action data as well. So we can send data back from the action if it were to fail or something like that. That's a different hook and a different set of data you might want access to in your UI. The action itself, again, it's receiving a request just like the loader. In our case, we're going to grab the form data, which comes in, and that contains the different variants we selected. So the size of the snowboard and maybe the material it's made of. We're just going to dump them into a JSON object for the time being and call this post to our cart endpoint, which is just going to throw that JSON in a local storage sort of mocked cart. So we make our fetch calls. If we get back a non-200 response, we're going to return an error from here. So we're not actually going to redirect. We're going to return JSON, and that's what's going to get exposed from our use action data. Otherwise, we're going to tell it to redirect back to the current thing, which means just stay on the page you're on, and that's going to recall all of the loaders. So again, one of the things we get by always passing through the, I think I missed it here. I want signal. No, we want to actually leave that. I don't want to interrupt that. So let's take a look at what happens if a user comes along and they like rapid click this add to cart, right? So that's another tricky problem to solve in e-commerce is like they want to hit this a bunch of times. How do we know how to get the latest data? Because we get automatic cancellation, we're sort of almost guaranteed to get the latest data back. So I can hit this 3 times real quick, and you'll see my count jump from 3 to 6. So all 3 of those post requests went out, and we made 1 revalidation at the end. And that's because those first 2 clicks that I did got canceled internally by the 3rd click. So it's never going to try to revalidate those. We're not making calls for all 3. If we click them at like slightly different cadences, and we actually let some of the revalidation start, we should see some of those like revalidations get canceled as well. So if I've submitted my mutation and updated it, and I've asked for the latest set of data, and I submit another mutation, we're going to cancel those fetches for the loaders and then call them again at the end. So there's some really neat built-in race condition cancellation interruption handling in this built-in router as long as you pass those abort signals along. And then I just want to show like the neat thing here is that we did nothing to our like get cart count here, right? So we didn't have to hook up the add to cart button and the cart count loader in any way. We didn't have to say like, go tell this thing to reload. Like if we just use the patterns of loaders and actions, that's all going to get handled by this router for us. All right, so that is mutations. Now I'll jump on to the last kind of 2 two new things here. Fetchers are really neat. Fetchers are, I'm not going to demo these, but they're interesting because sometimes you don't want to touch the history stack. So everything we've done so far is either a link navigation or a form navigation. And those are all putting entries in the history stack. You can choose to replace instead of push, but we're touching the history stack all the time. And that's not always what you want for your UI. You might want to do like a micro interaction in a page, maybe heart a product, sign up for an email subscription form, something that's not tied to the page you're on as like the critical path the user is going to follow. But you want to be able to make API calls, and it would be really nice if those could use the same ergonomics and same loaders and actions that we're using for navigation, loads, and mutations. So a fetcher is a way to do just that. A fetcher is given to you by a hook, so you would call use fetcher to get back a fetcher. For loading, it has an imperative API of fetcher.load, and you give it any route in your application. So you tell it to go reach out, and it'll call that loader. We're going to do this one in an effect, and then when the fetcher eventually has data, it'll show up on fetcher.data, and we can render this. So this is an example of like lazily loading the user avatar at the top of your page, so you don't have to have your origin be user aware or something like that. Fetchers have state on them, just like a navigation, so you know if it's idle or loading or submitting. So you can do local spinners based on that as well. The nice thing too is that fetcher loads, they participate in revalidation. So if you've loaded data via a fetcher on your page and you make a change from a form anywhere else, that fetcher is going to rerun its loading call and load the fresh data. You can also use fetchers to do mutations, and there's a declarative form there. So there is a fetcher.submit if you need the imperative API, but it turns out to be really nice to use this declarative fetcher.form. It has the same ergonomics of a regular form. You just put the method and action on there or leave them off and let the defaults kick in. Put whatever inputs and or buttons, and when you click submit, that fetchers automatically can make a mutation call in the background to the actions specified by this route, and that's going to trigger revalidation. So if I mutate via a fetcher, all of the active route loaders and fetcher loads are going to revalidate for me on the page. So it's just a really neat way. Sometimes if you don't want to touch the history stack and you just want like a little micro interaction, a fetcher is a really good solution for that. The last thing, and this is really, really neat, is the new defer capability of React Router 6.4. So when we used to do this like render then fetch, you would get to your destination page really quickly. It's kind of useless because there was nothing for the user to see there. It's just a bunch of spinners everywhere, but the routing happened really quick. In fetch then render, we are taking on the fact that we're delaying the kind of LCP of that destination page, the largest contentful paint. It's going to take a second to load data. And sometimes we have slow data. We're not always in charge of our APIs. We might need data from multiple different sources on a given routing operation. So sometimes we have to deal with the fact that we have slow data, and that's one of the reasons that this render then fetch approach makes sense, is that maybe you want to get them there and you want to give them a spinner to show them something's happening. Defer lets you separate your critical data from your non-critical. So the way it gets used, if you look here, this is an example of a loader we might have on a cart page. We need to get our cart items, and that's the critical data. We want that rendered as soon as the user gets there. We don't want a spinner for your cart items and make them think like, oh shoot, maybe they lost my stuff. But below that, maybe we're showing upsells and we're saying, hey, there's some other products related to the things you're about to buy. Maybe you want to buy them too. Upsells might come from a slow API. It might be third party. It might be running some like machine learning stuff to figure out what's related to your cart. So if we use this defer function here and we wrap our JSON object returned from our loader in defer, we get to choose by the await keyword which of those we should actually wait on and which ones we shouldn't. So by not awaiting this get upsells method, the return value is a promise, and we're just going to put that promise on the value returned from loader data. And then down in our component, when we call use loader data, data.upsells here is going to be just a raw promise. Again, using the platform, built-in APIs, nothing special there. And then we're going to use React Suspense to render the fallback. So when we have that promise, we can create a suspense boundary, put our own little spinner specifically for the upsells, and then we can use this await component. This is part of React Router or the Vue implementation, and we hand it the promise in the resolve prop, and then as soon as that promise resolves, it's going to render the children there and hand us the resolved data. So now we get the upsells, and we can render them in like a product tray or something. So this is really powerful for like certain parts of UI that are non-critical, and we're going to show you an example of the cart count here. So notice here the cart count is loaded. I'll go over to, this is fine actually. So we load the cart count along with the root loader. We get the nav in parallel with the cart count. Let's assume that this cart count was super slow. So I'm going to go over to my MSW layer. I'm going to trigger this cart slow thing, and that's going to cause our cart thing to take 3 times as long or something. So let me go ahead and reload. And you see we're just sitting on that loading screen. We've got a blank UI for a while, but if you look at our waterfall here, the collections, get that out of here. The collections finished pretty quick. That's our top nav bar. The product data loaded pretty quick. That's that. So that's all of the stuff the user came to this page to view. On a PDP, the important stuff is the product. And the header is probably relatively important too. The user doesn't need to see this cart count right away. There's no reason for us to hold up the rendering of our destination page just for this little number up here. That's a case where it's probably totally fine to have a spinner or have it just pop in. So what we're going to do is go over to our loader in the root page, and I'm going to go up here, and instead of putting this get cart count in the promise.all where it's going to get awaited alongside the collections call, I'm going to lift this out. So let cart count equal get cart count. We're going to leave the promise.all, but now what's important is I've kicked this off at the same time. So I haven't introduced a waterfall here, even though there's 2 different calls. I'm kicking this one off, but because I don't await it, then I'm immediately kicking off the next one. So they're going to go out in parallel. And then I'm going to change my response to use defer. Put in defer here. And now we're saying, okay, this data, that's actual data. That's not a promise at this point because we awaited it up above. Cart count here is just a promise. There's no data yet. It's not resolved. But I'm returning from the loader and saying, like, that's okay. You can finish the navigation. From a UI standpoint, we're not going to change anything here. We're still going to get our loader data the same way we did before. But now we can't just render this. That's a promise when we first come through here. So we don't want to render, probably show up as like object in the UI or something. So get rid of that. And we're going to bring in the suspense boundary, which is supported in Vue 3. For anyone who didn't know, it's pretty awesome. It was in beta for a while. It might still technically be called beta, but it works as far as I can tell. And the way we've wired this up in Vue, the way you do your suspense fallbacks, unlike React as a prop, in Vue it's a scope slot or a name slot. So we're going to have a fallback slot here, and this is going to render a little spinner while this suspense boundary is still pending. We're going to use the await component coming in from Remix Router View, hand off the promise to the resolve prop there, and then just this is sort of like the Vue way of doing things rather than using like a render prop in React. We're going to use the scope slot value. So we're going to get the resolved value whenever that promise resolves, and then we can render the cart count in here. I'm going to go ahead and save that. And now if I go ahead and do a hard refresh, you'll see that we get to render our page immediately after those first 2 calls are done, and we get a little loading spinner for the cart up top. And that can kind of come in whenever, right? That's not critical to our page. So it allows us to start to think about what's most critical to the user for this specific page, because that's what matters, right? We're doing these to give a better UX. So think about what's critical data for the user, wait on that, and then you can defer other things. And this gets really, really incredible in the Remix side of things where we can start to stream that data down. So Remix, once we get Remix on top of React Router 6.4, Remix will have this API, but it'll be streaming that. It'll start to send your document during an SSR request and stream in the data as it resolves. All right, jump back over here. So the last thing I want to talk about is just sort of the framework agnostic nature of this. If we take a look at like where we are now, we've talked about how we lifted these routes out of React Router. We've talked about how we've defined them as just raw JavaScript. So our router is now handling matching our routes, running our actions and loaders, bubbling our errors up to whatever route can display them, interruptions and cancellations, the URL, router state. It's doing all of that. But at no point in there is our router actually rendering anything. And that's what allows this to be framework agnostic. The router doesn't care how you're going to show your data to the user eventually. The router just cares about, I'm going to load this data for a given route because you told me what routes are in your routing tree. So it knows how to initiate navigations and fetches, and it knows how to kind of provide back to you the state of the world, the router state, and that's your loader data and all that stuff. You might be looking at this thing and saying like, hey, you've given this thing a JSX React component over here, so it's not framework agnostic, and that's just an implementation detail of React Router, the library. Under the hood, the only thing we hand off to this framework agnostic router looks like this. We don't give it the elements. It never renders, so it doesn't care. The one thing it needs to know, oops, I didn't have arrows, but this has error element true. That's the only thing our router needs to be aware of, and that's so that it can properly bubble errors up to the right level in that navigation hierarchy. It just needs to know, can this route handle rendering errors? It doesn't need to know how it's going to do that. So React Router actually takes this incoming data structure and basically looks for the presence of error element and swaps it over to that Boolean prop. So this is the sort of true framework agnostic API for the router under the hood. This is sort of what the API looks like if you were using it. Now, most folks will never interact directly with the Remix router. This is something that usually will only be used by like libraries like React Router and the Vue version of that. But it's there, and you can create a router given the routes. You give it a history. We still support memory routing and hash routing and browser URL routing. The router state contains things like the location I'm at, the data I have for my loaders, what routes are actively matched, all of that stuff you might need to know about the state of the routing world. It also has an optional active navigation if we're in the process of navigating. That's going to tell us the state we're in. So navigation is either idle or loading or submitting, which I think I left out of here. It's going to give you the location we're navigating to, so the path, the search, and the hash. And if it's a submission or mutation navigation, we're going to get the form method, the form action, the form data, and I believe the encoding type is in there too, which is just not in this screenshot. And then sort of the public API for that thing is initialize is what listens to, sets up all the history listeners and kicks off the initial data fetches. Navigate is how we tell that router I want to navigate to a new URL, and options is what you include your submission data in. And then subscribe allows you to subscribe and say, hey, whenever this router updates, tell me about it and give me the new state of the world through this callback function. So if we go back to the beginning, sort of like browser emulating lifecycle here, what we've done with this router is sort of found like, here are the things the router needs to be responsible for. The router knows how to match routes and fetch data. The router sets state. The router deals with history. But there's an entry point and an exit point in a way. So our UI, our React or Vue layer, has to render to the DOM, deal with click listeners, prevent default, but then it hands off to the router and says, hey, like the user clicked this button, they want to navigate here. We hand off to the router and we eventually receive it back through subscribe. So that gives us a really nice separation here of what the router is responsible for in a framework agnostic area versus what the framework aware layer is responsible for, which is dealing with the DOM and proxying those things to and from the router. So in order to create sort of a Remix router implementation, so React Router is an implementation of the Remix router. The Vue package we've been looking at today is an implementation of it. The rendering library needs to subscribe to the router state. In React, you would use something like use sync external store to sync that state down to your components. The router or the UI library implementation needs to be able to provide the router state down the component hierarchy via like context or provide inject and view. It needs to be able to create components that can do this DOM to router glue, so link and form. It needs to be able to render nested routes through an outlet component. And it has to provide APIs to access that router data, so hooks like use location, use loader data, things like that. There's not a lot to do there, though. There are currently two, pushing on 3 implementations of this. They're in my GitHub repo here. So there's Remix Router View is in there. Big shout out to Austin Krim, who did the Svelte implementation, and I think just presented on that at the Svelte conference in Stockholm, I think, recently. But there's a Remix Router Svelte package. I know someone, Brandon Roberts, did an Angular package. It's not in this repo, but he did an Angular version of this a while back. And we have a PR for Preact support in there as well. So we're really hoping that the community is interested in helping out with this. This is not a Remix sponsored thing. This is my own thing I've done on the side, but eventually Remix is interested in supporting Preact and potentially Vue as sort of native rendering frameworks. But they're not a lot of code. I looked at them both the other day, and they're about 500 to 600 lines of code to kind of provide this glue and these components that we need. And they both currently implement a subset. It's most of what you need from the React Router API, but neither of them are API complete yet. And they'll get there eventually as we keep finding time to work on them. But definitely check them out. They're pretty early on, so if anyone's using them, we would love feedback, bugs, anything like that. And just to recap, I think remember to use the platform. I wanted to just recap everything we used in this talk today. We used request, response, and fetch. We used promises. We used the URL and URL search params. We used form data, abort signal. There's probably a couple I'm missing, but these days there's just so much the browser gives us out of the box that it feels like a shame not to try to leverage some of it. So keep using the platform, and thank you for coming to the talk.